Hey tech lovers, you ever think of how your computer does a thing? Today we are going to dive into the basics. We will chat about what's inside your computer and how it interacts successfully. Whether you are a tech whiz or just curious, stay to the end for a simple breakdown as concerning what you need to know about your computer. You are welcome. I am Apollos Geoffrey by name. Let's begin with the question. What are computers? I can guess what comes into your mind after this question. You are beginning to think about desktops, laptops, and even smartphones. Well, that's correct. An interesting fact is that this goes beyond the knowledge of desktop, laptops, smartphones, and the likes. Let's take a look at a simple theoretical definition as collated by Encyclopedia Britannica 2022. A computer was defined as a programmable electronic device designed to accept data, perform specific mathematical and logical operations at high speed, and display the results of these operations. From this definition, there are key characteristics we need to identify. The first one, computers are programmable. This means any device that cannot be programmed is not considered to be a computer. Computers are electronic devices. Any device that are not powered by some sort of electricity are not computers. A computer has the ability to accept data. Means a computer should be able to accept some sort of instructions or commands. A computer should be able to process operations. This also implies that computers should be able to accept those data and then carry out some mathematical or logical operations on this data, hereby defining the processing ability of a computer. Processing operations or data at high speed defines one of the characteristics of a computer. A computer should be able to output meaningful information or results after processing input data or after carrying out some mathematical or logical operations on this data. Computers are known for accuracy of whatsoever kind of operations it's meant to carry. Computers should be reliable as well. Computers should have a storage capacity which enables it to store data. Computers should have networking capacity, which enables them to connect to other computers in order to exchange data. Elements of computers. There are components when put together makes up what we call a computer. We have the hardware components and the software components. We are going to proceed digesting the components of the computer hardware. These are the physical devices or components that makes up the computer. In clear terms, these are the components we can see or touch. It includes components such as the computer mouse, printer, monitor, microphone, scanner, and many others. The computer hardware components are further categorized or classified into four. Number one, we have the input devices, output devices, the processing units, and we have the storage devices. The image provides a clear illustration of how these different categories of devices interact or communicate together. Here the processing unit serves as the middleman, receiving data from the input devices, sending data to the output devices, and then receiving data to and from the storage devices. Let's proceed to understand the categories of computer hardware components. We would begin with the computer input devices. The computer input devices allows data and instructions into a computer. Such components include examples such as keyboard, mouse, scanners, and many others. Let's have a pictorial view of some of the computer input devices. Beginning with the computer keyboard, used to write or type in instructions into the computer. Notice that the computer keyboard has a lot of keys. We have the escape key, the function keys, mostly used for some sort of configurations. We have the numeric keys, we have the scroll keys, we have the alphabetical keys, we have the alphanumeric keys. The computer mouse, used to control the mouse pointer, usually displayed on the screen when trying to select one out of many options visualized in your computer screen. The computer mouse has basically two buttons and a scroll bar. We have the left button used to confirm a selection. We have the right button used to drop down more options when making a selection. We have the scroll bar used to scroll either upward or downward. The computer scanner. This is an input device that is used to scan any type of document into the computer. Let's proceed to understand the computer output devices. Basically, the computer output devices allows the information to be given out to the computer users. Basic examples of computer output devices include monitor, printer, speakers, etc. Take a look at some of the computer output devices, beginning with the monitor, a screen used to present information. Another computer output hardware device include a printer, commonly used to print out paper. Speakers are computer output devices that enables computer users to listen to sounds as outputs. Computer processing units. These are hardware chips that allows a computer to process data. They are also known as computer processor or the central processing units, CPU. Let's take a look at some of the basic components of the computer CPU. Number one is the arithmetic and logic unit. Number two is the control unit, abbreviated as ALU and CU respectively. Beginning with the ALU, it is the part of the CPU where actual data are being processed. On the other hand, the CU is a component of the CPU that controls and coordinates the flow of data between different components of the computer. In other words, the ALU is responsible for carrying out all forms of logical activities, mathematical operations, which includes addition, subtraction, multiplication or division, and all forms of comparisons, checking if the left hand is greater than the right hand, or the right hand is greater than the left hand, or the left hand is equal to the right hand. In other words, the CU interprets instructions received from the computer memory, directs the sequence of events that are necessary to execute these instructions. A practical demonstration of the different activities carried out by the ALU and the CU. Imagine the situation where you are summing two numbers. You have 5, you have 10. For these two numbers to be summed up together, the part of the computer responsible for adding up two numbers, subtracting two numbers, multiplying two numbers, or dividing two numbers. Take note that the numbers could even go beyond 2. You could have 3, 4, 5, or as much as you can. All these logical activities and mathematical activities are being taken care of by the computer CPU, more specifically the ALU aspect of the CPU. In the case of the CU, a situation where I press a button on my keyboard, an instance, I press letter A. The keyboard, which is an input device, takes this data into the computer and keep them in memory. The CU receives these instructions from the memory and applies appropriate action. An example of such action would be the result you see on your screen. If you press letter A from your keyboard, the CU take controls of this and displays it on your screen. Storage devices. Basically, the storage devices are hardware components that allows data to be stored, preserved, and retrieved. You can further see this as a place where computer keeps data for either temporary or a permanent time. Storage classification. The computer storage are classified basically into two. We have the primary storage and the secondary storage. The image provides more details about the two different types of storage with examples. The computer primary storage holds data on which the computer is currently working on. On the other hand, the computer secondary storage are usually used for either a permanent or long-term storage. We'll take a look at some pictures of the storage devices outlined in the image as well. Basically, this is an image of a computer random access memory, usually abbreviated as RAM. This is the picture of a computer read-only memory, usually abbreviated as ROM. This type of memory are mostly integrated in the computer's motherboard. This is an image of a computer storage called magnetic tape. We should be familiar with this to some extent, just that they are gradually outdated. An image of a computer magnetic tape. This is an image of a computer magnetic disk, popularly referred to as hard disk drive, usually abbreviated as HDD. This is an image of a computer optical disc, and they are usually slot into the system like this, basically through the CD-ROM. Here is a general structure of the computer system. We have data passing through the input units, also called the input devices, which includes our keyboard, scanners, and mouse as earlier displayed. Data from the input devices are being sent to the computer's memory or storage unit. This data moves to and fro the central processing unit. The same data is being sent out from the storage unit to an output device, such as the monitor, the speakers, or the printer. Here are the basic parts of a computer. A general image showing both input devices and output devices. The printer, the speaker, the monitor, the system unit, which contains the central processing unit, and in the central processing unit, we have components like the ALU, which stands for Arithmetic and Logic Unit, the CU, which stands for the Control Unit, and some other kinds of inbuilt memories like the registers and the cache, the microphone, the keyboard, and the mouse. Software. We've taken a look at the component of a computer system, which is computer hardware. Now we're going to dive into the second part of the component called the computer software. This is the point where things begin to get interesting. The computer software. A software is the instruction or commands that manipulates or operate a computer by enabling it to execute a particular task. In a nutshell, for a computer to perform a particular task or an action, a software is required. On the other hand, for a software to use any hardware components of a computer, that software must be programmed. Every piece of software carry out their actions based on how it has been programmed. If you've programmed a piece of software to only play music, that's exactly what it's going to do. All softwares are programmed or developed by some categories of computer experts we call programmers. A classification of software. We have the system softwares and we have the application softwares. Under the system softwares, we have subcategories which includes the operating system, the utility softwares, the language translators. Under the application softwares, we have basically two categories. Number one, the basic application software and the specialized application software. Now we need to understand what are system software. It is a collection of programs designed to operate and control a computer itself. In clear terms, system softwares are generally prepared by a computer manufacturer. And all system software products comprises of programs that are written basically on a low-level language. They interact with their hardware at a very basic level. We would understand the examples of low-level languages at the latter part of this video. Remember operating systems, utility softwares, and language translators as examples of system softwares. Let's briefly understand these three outlined with examples. An example of an operating system, a utility software, and a language translator. Examples of operating systems include Windows operating systems. The Windows operating system has continued to upgrade from Vista's XP, Windows 2000, Windows 7, Windows 8, 10, and even 11. We have the Linux operating system, includes examples such as the Ubuntu Linux operating system, the Fedora, the Kali, Red Hat, Parrot, many others. We have the mobile phones operating systems. It includes examples such as the Android operating systems and the iOS operating systems. We have the Macintosh operating systems, we have the Unix operating system, and many others, both outdated and trending. We have the antivirus, protecting your system against computer viruses. We have the disk cleanup, which aims at maintaining a good health of your storage devices. We have the file management system for preserving of files in an efficient way such that they can be easily retrieved from the storage. We also have the disk management tool that enables you to manage all storage devices on your computer. An example of a language translator software includes an interpreter, compiler translator softwares, which translate all high-level language programs or instructions into machine code that the computer can understand and execute. We also have the assembler language translator software. The assembler language translator translates assembly language programming into machine code that the computer can understand and execute as well. We've taken a look at the system softwares. Now let's take a look at the application software. Application softwares are basically designed to satisfy the particular need of a particular environment. They may either consist of a single program such as video players that are designed to play videos, or audio players that are designed to play audios, or image viewers that are designed to display image content. They may also consist of multiple or a collection of programs. Examples of these is the Microsoft Office package, which includes Microsoft Word, Excel, PowerPoint, Access, and many others. The previous image earlier displayed two categories of application softwares. We're going to take a look at these two with examples. We have the basic application software and we have the specialized application softwares. An example of the basic application software includes the word processors, which include basic examples like the Microsoft Word, the Google document, the LibreOffice Writer, and many others. Another example of the basic application software includes the internet browsers such as Google Chrome, Mozilla Firefox, Safari, Internet Explorer, Opera Mini, and many others. A video or music players are also examples of basic application softwares. This includes players like the KM players, the SM players, the VLC media player, the Kodi media player, the Media Monkey, and many others. You can find them online. And then we also have communication softwares such as the Zoom, the Team, Skype, Slack, etc. Now examples of specialized application softwares. The first example here includes the graphic design software, with examples including the Adobe Photoshop, CorelDRAW, Inkscape, Canva, and many others. It also includes some engineering softwares like the AutoCAD, Autodesk Civil 3D, SolidWorks, MATLAB, Simulink, etc. Accounting softwares are also examples of specialized application softwares, with examples such as the QuickBook, the Wave Accounting, SAP, which stands for System Applications and Product in Data Processing, the Mind Your Own Business application, etc. Video editing softwares are also examples of specialized application softwares. Popular video editing softwares include the Adobe Premiere Pro, the Final Cut Pro, the Blender, the Shortcut, the Kdenlive. We've taken some time overviewing the elements or components of a computer system, which includes the hardware and the software. It's high time we start talking about computer language, as this is the only way you can communicate to your computer. Just like you have a language you use to communicate, the computer has its own language, and you only use this to communicate to the computer. A computer language is a formal language that is used to communicate to the computer. It is also known as programming language and are basically meant for communication between humans and computers. The computer only understands one language, which is called binary language. It's basically a collection of some sequence of ones and zeros used to instruct the computer to carry out certain actions. The image provides an overview of binary language or binary codes, understandable to the computer. Yes, in early days of computing and programming, programmers did work more with direct representation of machine code, which includes writing core binary codes. All symbols, including alphabetical symbols, numeric symbols, special symbols, were all represented in binary code. This image provides an example of some alphabetical, numerical, and special characters and their respective representations in binary code, as well as ASCII code. ASCII stands for American Standard Code for Information Interchange. This is not the subject of discussion today, as we are more concerned about alphabetical, numerical, and special characters against binary codes. Programming evolution and trends. Here we're going to take a brief overview of the progression and changing trends of programming languages. Just like we previously discussed, the first generation of programming were more focused on machine coding. At the lowest level, programmers worked with machine codes, which consist of binary instructions directly understandable by the computer's processor. Instructions were represented in binary, such as zeros and ones, and these all correspond to specific operations performed by the hardware. For better understanding, imagine you grabbing your computer mouse and tilting it to the right. You tend to see that your mouse cursor on your screen is tilted to the right as well. This is because your mouse and input device has sent in some instructions to the CPU asking it to tilt the mouse pointer to the right. This actually happens, and therefore you see the result of this input through your monitor. Assembly language programming. This is more like a second generation of computer programming. Considering the fact that programming using machine code was complex and hectic, assembly language programming were introduced. This was to make programming more human readable, maintainable, and manageable. Assembly language uses some mnemonics and symbols that represent specific machine code. So programmers began writing computer instructions using symbolic representations, and then an assembler language translator system software were used to translate these assembly language programs into machine code, as machine codes are the only language understandable to the computer. Assembly language programming, since introduced, were not absolutely easy as expected, hence the need for high-level language programming, a third generation and even beyond. As computing continues to evolve, high-level programming languages were developed to provide more abstractions or behind-the-scene activities, thereby making programming more easier and accessible. Languages like Fortran, COBOL, Pascal, and many others were among the first high-level languages that introduced more abstract concepts, making it easier for programmers to express instructions or logical commands into the computer without directly dealing with machine codes. In a general summary, the progress in computer programming, which starts all the way from machine code to assembly language programming down to high-level language programming, has marked a change or a shift that has allowed modern programmers to focus more on the logical aspect of their programs instead of the abstractions behind how this computer hardware interacts, thereby making software development more easier, accessible, and efficient. The trend in high-level language continued with examples such as the C, the C++, the C#, Python, Java, many others. The image provides an example of a high-level language program written in Python programming language. While we are preparing to get into some serious business, there is need to introduce GPLs and DSLs to you. DSL stands for domain-specific languages. GPLs stands for generic purpose languages. DSLs are programming languages created to address specific problems in an environment or industry. While the general purpose languages are languages designed to be versatile, they are applicable across a wide range of environments and industries. I repeat, DSLs are developed for specific environments, while GPLs are developed to cover a wide range of environments. The generic purpose languages are commonly used for various types of software development, which includes web application, system programming, and many others. Let's take a look at these categories of languages with examples. A common example of the domain-specific language is HTML and CSS. While HTML stands for Hypertext Markup Language, CSS stands for Cascading Style Sheet. They are commonly associated with web development and can be considered DSLs because they define the structure and style of web pages globally. SQL, an example of a DSL language, stands for Structured Query Language, used for querying and managing relational databases. The R programming language is a domain-specific language used for statistical computing and data analytics. Some examples of general-purpose programming languages include Java, Python, C++, JavaScript, Ruby, PHP, many others. This clearly shows that general-purpose languages are also domain-specific language, while domain-specific languages are not general-purpose languages. So to sum it up, we've uncovered how computers work, how its components successfully interact with each other over time, whether you are a tech savvy or just getting started. I hope these things are making a bit more sense now. If you have any thoughts or questions about computers, feel free to drop them in the comment section. Also, if you have got a good time, don't forget to hit the subscribe button, give a thumbs up, and share to invite other tech lovers. Upcoming content will be grouped and organized into several playlists based on related categories. Subscribe for timely notification of new release. See you next time.